Okay, in this section, section B, we will be covering basic integration formulas. Specifically, we'll be exploring constant, addition, subtraction, and exponential integration. So first off, we have here, number one, we have the integral of k times f of x with respect to x, or dx. And as seen here, any constant can be taken out of the integral, as seen here, which would be k times the integral of f of x dx. Of course, k cannot be equal to 0, as 0 times f of x would be 0, resulting in the answer just being c, or a constant. Number two, we have the integral of the sum of f of x plus g of x with respect to d of x here, and that equals the integral of f of x dx plus the integral of g of x dx. Quite simply, right here, you can simply just divide the two up into f of x and g of x. And then number three, we have right here the integral of u to the n of du, which equals u times n plus 1 over n plus 1 plus c. And right here, take note that n cannot equal negative 1, as u to the negative 1 would also be equivalent to the integral of 1 over u du, which would actually be natural log u. Okay, so let's take a look at an example. We have example 3 in the Barron's book. The integral of parentheses 3 minus 4x plus 2x cubed with respect to x. So as seen in example 2, in section B right here, we can apply formula 2, which states that you can separate any functions. So as shown in here, we separate 3 minus 4x plus 2x cubed into their respective functions, the integral of 3 dx minus 4 integral of x dx plus 2 integral x cubed of dx. And then quite simply, integral of 3 would be 3x minus 4 integral x would be 1/2 x squared, as seen in section B number 3, which would result in 4 over 2 x squared, and x cubed again would be x fourth over 4 plus the 2 plus c. And then as a result, after simplifying, we get 3x minus 2x squared plus x to the 4th over 2 plus c. Moving on, we have some trig formulas that should be memorized for the AP exam. We have two basic ones: cosine u of du, which is sine u plus c. Sine u of du is negative cosine u plus c. We have tangent of u du equaling natural log of secant u plus c. This is correct, as if you differentiate this, you get 1 over secant u, and then you'd have the secant u and the tangent u on the top, and then the secant u's would cancel out, leaving you with the tangent u. Likewise, you can differentiate yourself for you can try differentiating natural log sine u to see, to make sure that cotangent u works, and indeed it does. So that's another one. Secant squared u of du equals tangent u plus c. And we have the integral of secant u du, natural log secant u plus tangent u plus c. Integral of cosecant u du equals natural log cosecant u minus cotangent u plus c. The integral of cosecant squared u du equals negative cotangent u plus c. And then finally, we have the natural log of cosecant u, cotangent u du, which actually is negative cosecant u plus c. So to wrap up this section, let's do one final example. We have example 24 in the Barron's book. We have the integral of cosine z over sine squared z with respect to z, which here we can simplify to cosecant z and cotangent z as a result of bringing one sine, taking a cosine z over one sine, which would become cotangent z, as represented here, and the other sine z, which is a remainder on the denominator, up to the top of the numerator, which becomes cosecant z times cotangent z with respect to z. And then as seen back here in the trig formula section, cosecant u cotangent u of du is negative cosecant u plus c. So remembering this formula, we can simply apply it here, and the answer would just be negative cosecant z plus c. And that wraps up section B.